A confusion matrix is a tabular form of results of a classification algorithm. It points out the areas of a classification model, where it predicts correctly or not correctly. Therefore, confusion matrix can be used to evaluate the performance of a classification algorithm. The areas, where the model is correct or wrong in prediction, can be located with the help of confusion matrix. Further, evaluation using confusion matrix can be applied to both binary as well as multi-class classification problems. A confusion matrix is always a square matrix. The number of classes determines the dimensions of a confusion matrix. Hence, it is obvious that the minimum size of a confusion matrix is 2 by 2, as in case of a binary classification. A typical confusion matrix is shown here. A confusion matrix has 4 main components. First one, as true positive, abbreviated as TP. Second is true negative, abbreviated as TN. Third one is false positive, abbreviated as FP. And, the last fourth is, false negative, abbreviated as FN. Now, let's try to understand the 4 components. Presented here is a table, showing few images of a dog and parrot. In the image dog, call it as dog, and in the image parrot, call it as not dog, as it's not the dog image. Hence, in total, there are 10 such images, collectively dogs and parrot. Now, let's first understand true positive, that is, TP. Consider the case number 1. In actual, it's the dog image, and, say it is truly predicted as dog. As, it's true and is positive as well. Therefore, we can call it as true positive, that is TP. Now, let's try to understand true negative, that is, TN. Consider the case number 2. In actual, it's the parrot image. And, therefore, it's, not dog. Now, say, it is truly predicted as, not dog. Because, the result is true, and, actually, it is true negative. Therefore, it is called as true negative, that is, TN. Further, now, let's try to understand the false positive, that means FP. Consider the case number 3 here. It's the parrot image, that means, it's not dog in actual. Say, it is predicted as dog, because, this is false predicted, and, predicted as positive. Therefore, it is called as false positive, that is FP. False positive error is also called as type 1 error. Type 1 error is just like saying, there is a problem when, there is actually not. Finally, now let's take the case of false negative. Consider the case number 4 here. In actual, it is dog image, say, it is predicted as not dog, as, the result is false, and, is negative, that is, false negative. Therefore, it is called as false negative, that is FN. False negative error is also called as type 2 error. Type 2 error is just like saying, there is not a problem when, there is actually. Same way, case number 5 can be resulted as true positive, that is TP. Case number 6 is interpreted as true negative, that is TN. Case number 7 is the example of false negative, that is FN. Case number 8 is false positive, that is FP. Case number 9 is false negative, that is FN. And, finally, case number 10 is true positive, that is TP. All the results are compiled in the last row, as final results. Now, it's time to compose the confusion matrix. For this, let's count the TP, TN, FP, and FN. So, TP comes out to be 3. Then, TN is 2. Further, FP is also 2. And, FN is 3. Now, TP, TN, FP and FN are arranged in a confusion matrix as shown here. And, here is the confusion matrix for the classifier's prediction under test. Now, what does a confusion matrix say? TP equal to 3 indicates that, 3 actual dogs were correctly predicted as dogs, while, FN equal to 3 means, that 3 actual dogs were predicted as not dogs. Therefore, this is the area, where classifier needs to be corrected. Similarly, FP equal to 2 indicates that, 2 not dog cases were predicted as dog. And, finally, TN equal to 2 indicates that, the 2 not dog cases were predicted as not dog. A confusion matrix is associated with 3 important metrics, namely, precision, recall, and F1 score. Precision tells how many of the instances predicted as positive are, actually positive. Recall shows the proportion of true positives detected, out of all the actual positive instances. F1 score provides a better sense of a model's overall performance, particularly for imbalanced data sets. Here are some of the frequently asked questions on confusion matrix during interviews. It's quiz time now. To submit your quiz response, please click on the Google form as marked below in the comment section. Type your response option against each question followed by comma and submit. All are multiple choice questions. Only one option is correct for any of the question. Select the proper option and put down in the Google Form field. After submission of Google Form, you should get the score analysis in few hours from Academy. Wish you a very good luck.